Hello class, this is Mr. Kusaj, and we are ready to start chapter 6. Chapter 6. So today we did our chapter 5 test. I hope you did well in that. Don't bother asking about it tomorrow because it'll take me a few days. There's 4 classes, so it'll take me a few days to finish grading all of them. So hopefully by the end of the week I'll have the results. Anyway, on to chapter 6. Don't forget to write the date here. The title of the chapter: Pythagoras Theorem. What is Pythagoras Theorem? Well, I don't want to give a long history, but there was a man, and his last name was Pythagoras, and he found out that this happens in all right triangles. What happens in all right triangles? Well, first of all, let's talk about the right triangle. Every right triangle has a right angle and 2 legs. Okay? The legs are the 2 sides that make the right triangle. The L shape, those are the legs. The diagonal is called the hypotenuse. So leg, hypotenuse. And you know how in math we like short notation, short symbols. So we call the legs A and B. It doesn't matter which is which. Okay? Leg. Whether you call this A or B, it doesn't matter. The legs are known as A and B. And the hypotenuse is known as C. So what this guy discovered was that if you square the legs, add them, they always come out to the square of the hypotenuse. Okay? Now, this is, if you think about it, it's amazing because it works for all right triangles. Okay? So let's see it in action. Let's see it in action. So here is the first example. Suppose you had a right triangle and we're missing a side. So the legs are 2 and 3, the hypotenuse is x. So if you think about this as like a formula, we have 2 of the letters and we're missing 1 letter. So all we got to do is plug in the numbers they give us and solve the equation, solve the formula for the letter that's missing. So I'm going to plug in the 2 and the 3 right there, and it's going to look like this, right? So again, the legs A and B, it doesn't matter which one is 2 and which one is 3. Because if you think about it, you're just going to add them anyway, so it doesn't matter which order you're going to add them. The hypotenuse, we don't know what it is. It's x squared. I'm calling it x squared and not c squared because in this particular problem, they call it x. In the original formula, they call it c, but here they're calling it x. Okay? So now what? Well, now let's solve the equations. We do order of operations, right? We do exponents first. So that's 4, that's 9. 4 and 9 is 13. 13 is equal to x squared. Done. No, that's x squared. We want x. So how do you get x? Square root both sides. And voila, x is equal to square root 13. That's it. That's basically it. A few things to talk about, some details, but that's the gist of Pythagoras Theorem. It works with any right triangle. So as long as you're missing 1 part of the triangle and you have 2 parts, you can find that missing 1 part. Okay, first, before we go on to a second and third example, let's talk a little bit about accuracy of answers. Notice that this one came out to square root 13. And a lot of students are going to ask, do I leave it like that or change it to a decimal? Well, it all depends. It all depends on the instructions. Now, the instructions might say, give the perfect, accurate answer, right? So you leave it as a square root, right? So square root of 13 is exact. That's the perfect answer. But if somebody wants an idea of exactly how much that is, okay, then we can approximate. we can't give the exact value in decimal. We can only approximate. So if you hit the calculator, this is what it will give you. And it will keep going. It'll keep going forever. Okay? And that's why they call it irrational, by the way, but that's another story. It keeps on going forever. So the best we can do is approximate or round to the nearest what? To the nearest whatever is asked for. Okay? That's 3.61 if you're rounding to 100, 3.6 to the 10th, and so on. So if they want the exact answer, then you leave it as square root of 13. If they want an approximate answer, then the instruction will say approximate to the nearest 10th. So you give this answer. So all you have to remember is exact answer, you leave it with the symbol, right? Approximate, you change it to a decimal. Okay, so let's look at a couple more examples using Pythagoras Theorem. Okay, look at this example. This is the second example. So in this one, notice the legs, A, B, and the hypotenuse, 6. So now if we put these into the formula, right, the 6 is out here by itself now, because that's the position of the hypotenuse. Remember? Leg squared, leg squared. So we have to put the legs here, leg, leg. And outside here by itself is the hypotenuse, which in this case it happens to be 6. Right? In the other case it was x. Now the leg is x and the hypotenuse is known. So we square everything, right? Because that's what the formula says. Now we solve. I want to solve for x. So first, let's get rid of the exponents, right? 25, 36. Minus 25 on both sides. All I'm doing is solving the equation. X squared equals 11. So x is square root 11. Or x is 3.3, depending on which one we're looking for. Okay. Third example. In this example, if you look at this example, you notice that you have a square root of 10 here. Right? This is the first time we're seeing a number that's a square root. Right? All the other ones had whole numbers. Well, it doesn't matter what the numbers look like. You are going to follow the formula, which says leg squared plus leg squared equals hypotenuse squared. So I'm going to put these three items, the two numbers and the x, in the correct position. Leg, leg, hypotenuse. Wouldn't they or won't they look like this? Right? Leg squared equals hypotenuse squared. Now I solve. So notice that the legs are both on the same side. So I'm going to square both of them and then put them together. So this becomes 4. This becomes 10, right? Square root of 10 squared. The square root and square cancel. So this becomes 10. 4 plus 10 is 14. So x is square root of 14 or 3.7. There you go. Or 3.7. Sorry. Okay. So again, it doesn't matter what the numbers look like. This could be a decimal. It could be a whole number. It could be, it can't be a negative number, right? Distances can't be negative. Okay. And did you notice that we always came up with a radical answer? Well, most of the time, not all the time, most of the time, you are going to come up with a radical answer, which turns into a decimal. A few times, and I'll show you tomorrow, you will come up with a whole number answer. And those triangles, there's very few of them, those triangles are famous. Okay, why? Because they come out to whole numbers. Not very many of them come out to whole numbers. Okay, let's look at this is very short. It says 6A.1, more Pythagoras here, but it's very short. Just one more example. If you look at this example, in this example, we're going to deal with what if one of the numbers, or both the numbers, what if one of the numbers is a fraction? Well, remember we have to square it, so do you know how to square a fraction? So going back to chapter 5, squaring a fraction means squaring top and bottom. So a over b squared means a squared b squared. You square both parts. So we still follow the formula. Leg squared, hypotenuse squared. Right? So leg squared equals hypotenuse squared. So this is x squared. We're looking for x. 1 squared is easy. That's just 1. But what is 1/2 squared? Don't say 1/4. Well, actually, it is 1/4, right? 1 squared, 2 squared, right, is 1/4. Now what? Well, I'm looking for x, so I have to subtract 1/4 from both sides. Minus 1/4, minus 1/4. And now, whether you can do it in your head or not, well, you can find common denominators. You could do it on paper. But again, if you have a good calculator with fractions, just hit 1 minus fraction 1/4, and you'll get the answer. X squared equals 3/4. Done? No, that's x squared. So we have to square root the 3/4, right? And square root 3/4 means square root 3, square root 4. Right? Square root 3 can't be done, but there is an answer for square root of 4. There's the answer. X is equal to square root of 3 over 2. Okay, so I'm done. So what have we learned? The theorem, right? The formula, a squared plus b squared equals c squared. Right? There's the formula. We learned that. And then we learned how to plug in the two numbers they give us in the correct place. Sometimes it's leg, right? Hypotenuse is missing. And other times, one of the legs is missing. We have the hypotenuse, one of the legs is missing. So depending on what's missing, you put them in the correct place and solve. And one final thing that we learned was, and this is important actually, leaving the radical symbol is the way to give the exact answer. By changing it to a decimal, you are given an approximation, an estimation, a rounding, whatever you want to call it. But this is not an exact answer, right? Because it keeps going forever, so wherever you cut it, it won't be exact. This is the exact answer. In fact, not to get into detail about this, but that is exactly why we have a symbol, because the exact answer cannot be written, so we have a symbol for that situation. So we refer to this as the exact answer and this the approximate answer. Okay, should I show you the notes one more time in case you want to pause and make sure you copied everything? So we started with this. We started with this. Then we went to one example, a note, another example, a third example. Then we were wondering what happens if one of the numbers is a fraction, and we used a fraction in our example. This was the last example. And that's it. So tomorrow we'll get straight to the assignment, and all we will do is just practice, practice, practice. And you can ask all the questions you want. It'd be a good idea to circle anything here, put question marks anywhere here that you didn't understand. But all we're going to do tomorrow is practice what you just saw here in the video. That is 14 minutes and 15 seconds. Not bad. My goal is to always keep it under 20 minutes. Okay? So see you tomorrow. Good night.